Aufnahme starten, that seems easy enough. Wonderful, so I'm talking to this AI-powered thing here to track me. Do it, please. Do it, please. Yes, it does. Wonderful. It does really do it, okay. So first of all, great to have you all here. I already joked I have already 3 hours of work in today, so I'm gonna quit early and you can do the 3 hours then later without me. No, I guess that's not how it's working. Also, my jokes are not good yet. That's very embarrassing. Let's start with a little bit of housekeeping, first of all. So we have some things to help you get through the day. You might see outside there's a freezer. I turned it off now because there's a lot of energy drinks in there. This small energy drink company was kind enough to sponsor us with drinks this weekend. It's mostly energy drinks. If you're not into that, there's a little bit lemonades. Unfortunately, other than last time, we did not have budget for anything, so we needed to take what we could get, and I think that's very kind of them. And the little budget we have in the afternoon, and this is making it really worthwhile for you, we will have some ice cream outside this lecture hall, and you all get some free nice ice cream. This is the one thing. The other thing is what I also just learned is that there is this noon to afternoon a film production in this part of the building. It's apparently in the first floor, so it's below us. But please know when you leave the room and do whatever you're doing that there might be people trying to get good audio, good video, and might be disturbed by, for example, you taking a phone call or whatever. So keep that in mind. Nonetheless, we should get along well. I did not know that beforehand. They apparently don't know that we are here. So I'm looking forward to the moment that they come in and want to shoot a scene in here. And that is that for the localities. I know the location here is a little bit hard to find, but I think it's worth it with the wonderful view. The other thing you might have already noticed is that TUM is in general very short of power outlets. So whenever you have to charge your device, best do it in the breaks. I saw there are 2 power outlets there, 2 power outlets here, and 1 more here. So that's apparently all you need in a technical university, but still that should be fine, I hope. Wonderful. So let's talk a little bit about history. So this is the second iteration. I do this, and the third iteration we do it in total. The first iteration, for those of you who have been here, I'm not sure if somebody has been there, you had a lot of super productive feedback, which we try to incorporate. And one of those feedbacks is that we try to make some kind of way to make the contents accessible to you. One of the contents, of course, will be the recordings. Another one will be the slides. And I built a website which you can access there at the t12s.de, where you see a lot of the services that I built in the last year, including co-founder matchmaking and other stuff, but also the microclasses are all there, and then you can self-serve yourself. There are some modules on the website that are not on here. For example, I built a small introduction to Python course. If you're into that, might be relevant for the second AI microclass if you are planning on coming there. So that might be interesting. So this is a website that you might want to bookmark, at least for this course. Wonderful. Let's start with a very short introduction of the TUM Venture Labs. Of course, you know them, otherwise you probably wouldn't be here. At some kind, you need to have found this through our channels. We are a part of TUM and also a part of Unternehmertum. And the thing that we try to do is we try to motivate and encourage and enable everybody, of course, but in particular researchers and people with a stronger scientific background to become entrepreneurs. From my physics background, I know that we physicists tend to do some great research, put it in 1 paper, 2 papers, 3 papers, and then completely forget about this. And nobody really reads these papers anymore. And I think this is such a waste of potential when you develop something that could improve the world, that could make a very small part better. I personally think that entrepreneurship might be a very viable way to go. And this is what we're doing. I'm in the venture labs of software and AI. Hence, I'm lecturing this course now. But we also have other venture labs. Ruby, for example, in the venture lab Quantum, I try to motivate him to do a microclass on chip development, which would be super cool. So nudge him in the break to make him do this. And of course, whatever your background is, you will be right with us. Also, that's important for you if you're saying, okay, you are a scientist or you want to start something. Where do you start? You might know that in the TUM ecosystem, it's very much you have Unternehmertum, then you have Explore, Expreneurs, you have all these cool programs, but there, in general in the ecosystem, there's no wrong entrance way. So talk to whoever, talk to me, and in the worst case, I can guide you to the probably most appropriate person or institution that might be able to help you in the particular moment. I brought a small code of conduct that I try to establish, or we try to establish in the venture labs in general, how we want to work together in everything we do, and of course also in the micro classes. And the first very important point is I think that we only can grow as a community. We are all very short on time, on resources, on everything we have. So here we are a huge community and we want to grow together. That is what I expect from you. You see the Slido links already on the wall. I will also show it to you when we get to our first Slido. I expect you to give me feedback, how I can be better, how I can improve, how we can make this format better. You can expect from me that I give you candid feedback on what you can do better. And of course, I also would wish for you to give each other feedback when you're stuck on an exercise, when you don't understand something, that you just help each other. We also stay true to our word. I think in particular for this class, this mostly stands to me, that when I say I do this 2 days, then of course I do these 2 days. But I also would expect that from you. If you say you want to take something out of this course, come to me, say, let's think how we can implement that. But then I would expect you to stick to it and just to do it. And what you can take out of this course, you'll see in a second, it's really a lot, no matter what you do. If you're in research, in corporate, in entrepreneurship, I think there's a huge potential for improvement on whatever you're doing. And lastly, we like hustling, but let's keep our focuses right. Let's prioritize our health, our team, our product, and in that order. So let's take a look at ourselves first. I know this is a weekend which should be time for ourselves. I, for example, probably will take the Tuesday off because I need to focus a little bit on my health after that. But this is really important. Don't always hustle. This goes particularly out to some people who are rather young and whom I know that they are always trying to go as fast as possible. That makes me sound old when I say it like this. Okay, today AI practitioners microclass. The AI part of the microclasses will be in 3 microclasses. Each microclass will be on 1 weekend. The first one, of course, is today. Today we will take a general look in artificial intelligence, how it works and how we can build assistants with it. Today is mostly on text generation. Tomorrow then will be beyond text generation, how we can create images. We will very much focus on the example of images, but that will also hold true for audio generation, that will also hold true for video generation, and every other kind of asset that you might imagine. Also tomorrow, which I'm very happy that we have there, as Richard will come from Evolution Rechtsanwälte and talk about the legal aspects of AI. What can you do, what can't you do, what should you do, what shouldn't you do? So this, I think, will be a very interesting thing, also for more the entrance level. Then the AI creators, which will be in the end of July, as you see there, will start basically where we leave off. It might make sense to have some first experience with coding, for example, Python coding. As I said, I will put the self-paced, go on your own paced course that I built for Python on the T12S website, then you can learn up on this if you haven't done it yet. And in the creators, we will learn how we can use what we get in APIs, in very nice frameworks, very simple frameworks, to build our own services based on AI, or how to implement AI in our services. And then the third one, which will come in October, which will be AI operators and focusing very much on ML ops. I'm thinking of framing it a little bit to the direction of DevOps, so being more engineering heavy. So if you're an interested guy who's not that much in engineering, that will be super interesting to you as well. Otherwise, I would consider the AI operators rather a technical class. So what are we doing in the microclasses? Why actually do we call it microclasses? Of course, we called it microclasses because we were on a tight deadline and we needed a name. But I'm actually quite happy with the name because it's very condensed. So we start with a introduction to whatever topic we have in, let's say, 45 minutes, 30 minutes, depends. You will see it on the schedule. But then also we try to directly apply that. So you will also have some work to do today and try to apply whatever we are doing. So if you already come with a specific problem that you want to solve, that would of course be fantastic. Then you can just work on that. And in the end, after the exercises, we want to discuss what did we learn, what did we observe. This in particular for an AI microclass is important because AI is just moving so quickly, in particular generative AI is moving so quickly, that I actually have one example where something that worked the last iteration, which was in October, perfectly fine, doesn't work anymore because in that particular case, ChatGPT was just moving so quickly over the last half year that you do not have any repeatability over the outcomes that you try to get. So that is what does it mean if you're a potential founder or you're considering founding? Then it's about learning how to do it, how to apply it, and this is probably the difference to a classical university course. I don't want to teach you how a computer works on a transistor level, but I want to teach you how you can open Word on a computer and work with it. Does the analogy make sense? So how to apply it rather than opening PyTorch and building your own neural network, which is fun and surprisingly easy, but not part of this course. So this basically recaps a little bit of the code of conduct. We have people of all expertise here. Who has some prior coding experience? Wonderful. Who has never seen a single line of code? Also, see, there's really everyone here. So of course we try to be open. If something is too slow, then be patient. If something is too fast, then please let me know. Then it doesn't make sense if we just jump over things because they might seem too basic or too simple. There's no wrong question. There's no stupid question. So we try to help everybody understand everything. Also the exercises, also take this time to make your own experiences and take the time to talk to me and think, okay, is this on your level? Do you need it a little bit faster? Do you need it a little bit steeper? Do you need it a little bit slower? We can adapt to that, so the exercises are not like the classical homeworks that you might get in university. It's only to help you understand and apply the concepts that we have. Contribute, be helpful, have fun. It's a Saturday, we want to have fun today. At least that was what I had planned. And if you see somebody next to you struggling, then please help him or her, or if you think you can contribute something, then please do that. Of course, what I would love to see is if somebody of you comes out and starts a business actually with what you do. If this is not enough, you will also see in a second, I have planned a ton of other micro classes that might help. There's also a process to my madness. But if you have the motivation, talk to me and we will see how out of that, what you have here, we can get you to create a startup. It is not so important. And of course, it's 2 intense days. Don't underestimate that. That's what I wrote yesterday shortly in the email. Bring water, bring something to snack, bring everything that you need to stay hydrated, to stay energized. Of course, also if you feel very, very tired, I know that a frontal presentation over an elongated time can stay very tired, then go out quickly, make some stretching, and try to be as energized as quickly as possible. I know how hard it is. I know it from my particular physics courses, how hard they can be. In the physics department, of course, you don't have windows on lecture halls, because why? That would just be a waste of resources, right? So it's also very, very dark, and I got so tired all the time. So what really helped me is just go out, make a little bit stretching, and come back in. So be present or be elsewhere might be a little bit harsh, but if you really feel like this is nothing for you, or you don't have the concentration, feel free to go to the Pinakotheken, to the Englische Garten, or do whatever you please. This is again how we want to structure it. So every topic will start with a theoretical input, what this concept means, what it means on a technical level. Why is this important? Of course, that we understand what we do. All the slides are, by the way, completely online already, also in a PDF. You can already download them. So have a basic understanding of the concept and be able to adapt the concepts or transfer the concepts to other parts where they might apply. Then we do a practical exercise. And then, of course, the application part is something that you do at home. On every day, I will give you some homework. Of course, I won't control you if you do the homework or not, but it's some suggested thing that you can do, should do, would do, if you wanted to continue with the contents of the course. T12S, I've already told you about this. It's a very simple website. I just built in a couple of days with a tool called Software. What you will find there is, of course, all the contents for the website. So I put all the repositories that we have for every course here. There are all the sign-up links. There is the sign-up links for all the courses. There are all the recordings for all the sessions. Not yet, of course, because we're recording this right now. And there are all slides, exercises, additional materials. So I basically try to make it a very simple kind of course management system. Everything open, don't have to log into anything, everything for free. This, of course, being one of the things that we try to stand for as Tom Venture Lab: open, free, and open source for everything. You can use the slides also if you're interested to share them and do whatever. So everything you can find with a click of a button there. So I was quickly talking about the method to my madness, and I think this is what it boils down to. When we are at the very early stages of creating something, in the cases I'm interested in, mostly a company, then we go through 3 distinct phases. Of course, it's a framework, it's a kind of simplification, but I find this to be insanely helpful. The first phase, the first process is ideation, where we start with smart, driven, engaged individuals, people like you that are here in the lecture hall. And through a process who you want to get at a point where you have a full team, so you have all the capabilities you need to start a business in your team. You have found a problem space that you're motivated and go on. And there might be 3 constraints that you might be facing. Maybe you don't know what you need to know to start the project or to conduct the project. Second, you might not have the team, you need to find it. And third, you might not know what problem you might be solving. One problem that a lot of technical students jump to is they try to force a solution to the market and don't even know the problem yet. Including myself, I'm also guilty of that, or used to be guilty of that. So we help you with everything. The microclasses are the part in the early stages where we just try to tell you just enough for you to get started. And of course, it's a service on the T12S. We also have a co-founder matchmaking. If you say, okay, you also do want to start something but don't have the co-founder yet, also on T12S is the co-founder matchmaking, and I'm building an opportunity tracker when I do have time for that. Daria, we don't have too many resources at the lab, so when I get to it, I get to it. I unfortunately cannot tell you when exactly this will happen, but this should then help you to get through the first phases of your project, whatever it could be, in the fastest way. So what else do we have prepared for you? If you say, okay, this is all nice, but I need to know more, then I have a bunch of other microclasses. I already told you it's one a month, and it's really a lot of work. I need to find a way to make this a little bit more automated. Let me see if I can do this. I can, but it's not good. Yeah, it's okay. Okay, so you already have missed 3 microclasses that don't worry about that too much. We're planning on doing this annually. So we're today in the AI practitioners microclass. The next microclass, which will be in a month from now, roundabout, will be on prototyping and product management with low code. This will be probably a super interesting microclass if you're interested in anything of building something, either because you want to automate workflows or you want to learn how to build any kind of solution within a couple of hours. We will learn a lot of how to use low-code tools, how to use databases and stuff like this. In this class, this is probably the most important class if you're really serious about starting a scalable product. The month after, as I said, is AI creators, which might be a little bit more technical. We have a little break in the summer. And in September, we start with Web3 and blockchain. This is, again, a less technical class, so it might be interesting for you if you know how to buy crypto, but do not really know why it has some value. Then it might be interesting for you. So we learn how to build our own token. We learn about all the important processes there. We learn what Web3 actually is, if it will be a thing or not. I think the dices did not fall on that. So that might be interesting. AI operators, then again, a rather technical class which you might be interested in. October, yes. In November, we're building hardware and 3D printing. So this might be super interesting if you actually want to build hardware. I had a startup hardware once. I cannot recommend it, but for projects that you do on your own, for hobby projects, it can be super cool. So we will learn how to build on the Arduino platform, and we will learn how to do 3D printing. That might be cool for you, and you will go home with your own self-built piece of hardware that you can use every day in your home. What project exactly, we don't know yet. We're thinking about that. And then we end the year with a class on hacking and cybersecurity. Of course, cybersecurity is a super important topic right now. And we will learn 2 things. First, how to stay secure, and second, how to hack. So how to enter cyber-physical systems, which might be super interesting. It sounds super technical, but actually it's not so much. It's surprising how deep you can penetrate systems, also protected and secure systems, without having to know too much technology. So this might also be interesting, even only if it's just for you to keep your password safe and to keep your login safe. And of course, all of them, T12S is your friend. Bookmark the website, would make me very happy. And this is the role in a startup that you might have, that that I would recommend you you take the courses then. Wonderful. Some words about me. I'm Basti, and I'm at the moment very tired, which is very saddening. But as you see, I'm already looking forward to Monday when I do not have any hard lesson. Why am I so tired? Because last week I handed in my dissertation. Then last week, Thursday, Friday, I had a two-day full day seminar in Leipzig, and now I have this. So I'm so much looking forward to Monday where I do not have to prepare full-day presentations. This will be very cool, but I also love that very much. I love very much, of course, being here with you, so it's no complaint. What is my day job? I'm the director at, where is it? Not even here. Yes, there it is. I'm the director at the TUM Venture Lab Software and AI. Why have I some competence in telling you how startups work? Because I have failed 2 startups. The one was called Blick, it was a hardware startup. The other one was a direct-to-consumer startup called Paper Turtle. So I know a lot of things that don't work and can tell you a lot of the things what not to do. Also, of course, I've done a lot of things that did work and can maybe reflect with you on what this can do. And you can also see I have I liked studying, that's why there are so many titles. It's not because I'm very smart, but I just really loved being a student. And now the doctoral thesis, as I said, is also handed in, so I'm finally out of that, which also is fantastic. And yes, I will be your host for today and tomorrow, your captain of this learning journey. It's kicking in, the Red Bull is kicking in. And this will be fantastic. And as I said, tomorrow afternoon there will be Richard, and maybe tomorrow morning there might be my colleague Jan, but we have not decided on that yet. We'll see how the day goes. We're through with that. Interesting that this doesn't work. So that was the opening. Oh, I'm over time. I'm so sorry. This is the plan for today. So I think we're now starting with a very, very interesting thing, the introduction to AI and generative AI in general, rather technical. Then we go in 2 sessions in prompt engineering, and we'll have our exercises there. We will have breaks in that between. Also, if you say you're just tired, and or if you have the feeling, or if I have the feeling that you're tired, we might make a small break in between. No worries. The next coffee place, by the way, might be the Müller at Gabelsberger Straße. If you need a freshly pressed coffee, that's where you probably get this. Wonderful. So today, as you can see, a lot of prompt engineering. If you say, oh, that's all an old hat, I might agree. For prompt engineering basics, in the advanced techniques, there's mostly new stuff of the last half year. So even if you feel like you know the first the basics of prompt engineering, for the advanced stuff, you might want to stay around. And then when we go to AI assistance, this might be where you really can accelerate your AI game. Okay. Oh, did I put this here? Oh yeah, why not? So let's head on to slide right again, and let's do activate survey icebreaker. Yes. A small icebreaker to get some engagement. I learned that it's very important to have engagement with your audience. Then we broke the ice as well, and we can talk about the introduction to AI and general AI. I have 3 things brought for you. First, some general notes about AI, then about generative AI and LLMs, and then we will look about LLMs under the hood, which will be super interesting. We were looking at GPT-2 basically, and in all its levels of detail. So when we start with AI, then first thing, of course, we need to understand is that AI is not AI, but AI is a huge set of tools that is very, very versatile. It's a little bit like Jan Bastian, my colleague, made the comparison that it's a little bit like electricity. You would not say, okay, electricity does this and that. It very much depends on where you apply it. And the same, of course, is true for AI. You have so many application fields of AI, which we will see. And no matter what business you're in, no matter what you are using, you will be using AI. Something that strikes me as very odd is that companies, including the one I'm working for, are trying to regulate the usage of AI when it's basically impossible, because this webcam has AI, this computer has AI, my watch has AI. So it doesn't really make sense to say, okay, we try to regulate the usage of AI on a tool level. You will use AI no matter what you do, the same way you use electricity no matter what you do, the same way you use computers no matter what you do. The question is just, do you understand it and do you use it to your advantage, or are you a passive consumer and being overrun by the thing, by the AI thing? Nice anecdote, when I got the keys for this lecture room this morning, I of course needed to go to the Pforte, and the very nice gentleman there, when I told him what I had planned today, was very skeptical about AI, but he also did not understand it, and he was worried that AI would take his job. And I think this is only true if you do not evolve your job in a way that you use AI. He, of course, was sitting in front of a computer, and if he would have the same reference or same attribution towards computers, then he probably would not have his job today. So it's again moving with the times, and I can also see that it's a little bit frightening, because in the last couple of years there was really a lot of progress that we have made, in particular in generative and AI and large language models. When you look at Wikipedia, then you of course can also see that in basically everything. So this is just a Wikipedia overview article, so it's not even an in-depth analysis of what AI is doing, but you see no matter what you're doing, there is AI, and there is the opportunity for AI in it. Which of course begs the question, when everybody says there's AI in everything, why is the only AI thing that we have a small ball on the kitchen counter that cannot even understand if we want to know the weather or not? And of course the answer to that is manifold. One thing is that AI is not AI. Do you know what the Gartner hype cycle is and how to read this? Yes? Okay, wonderful. So for those who do not know, is basically the Gartner hype cycles for every kind of technology or every kind of technology field always has this curvature, and the information that you put in as Gartner is the data points. And basically what you're saying is in what maturity level is what technology. And what we in particularly see with AI is that we are very, very hyped right now with generative AI, for example, with edge AI. Those are the things that we work with every day. So Siri on device, that is a super hyped topic. ChatGPT is a very hyped topic. But of course, those are just two things. Generative AI is just possible because of a paper that came out in 2017 and some advancement in semiconductors that just came out recently. That is only like this. So I would actually say that this is now of 2022, that we actually a little bit over this curve with Gen AI. And what we probably will see in the next couple of months is that we have a valley of disillusionment and say, okay, it's still just a tool, and the entire talks about, is this now general intelligence? I can assure you it's not. It's a tool that gets us words in terms of a large language model. If you create songs, I will show you some tools tomorrow. I like playing music. I also like composing a little bit. I'm not really good at it, but I enjoy it very much. And it's interesting how good AI can compose music. But once you understood what it actually does under the hood, you understand that it does that and just that and nothing else. And the same, of course, is true for AI. We have a lot of things that are very mature. Computer vision comes to mind. So we had this discussion. Somebody came up to me with the question that he does not want AI in his car, but then every car has this feature where you can read road signs, and this road sign reading, of course, is computer vision. It's of course AI. So every car already has AI, if it's a Tesla or not. It doesn't really matter. So this is basically the hype cycle. There's AI. There's so many tools in AI. The adoption, of course, that we have in AI is a plan to explode, also because executives now understand why it's so important and what you can do with it. So you're in the right spot learning about it now and not learning about it in 5 years when the train has already passed. And then, of course, the AI field is just very huge. We have a lot of tools in AI. It's from a scientific perspective, it's a super interesting topic because it has a lot of mathematics in it. There's a lot of data science. It has a computer science in it and other stuff. But then you have a subset of that, which you might also have heard, which is called machine learning. We will go into how machine learning works on a technical perspective, I think only the second micro class. Today we will look at, and today and tomorrow we'll look at neural networks. But machine learning is a very huge set of AI, but there are also tools that are AI but not machine learning. And then in this field of machine learning, which can be done with a lot of different techniques, then inside there is the deep neural network. And the thing that I would like you to take away from this is, without understanding exactly what is, that AI is not machine learning and machine learning is not neural networks, but there are neural networks, or there is machine learning that uses neural networks, and AI is basically the big overarching topic that everybody's talking about. And somebody throw around these names as if they were the same thing. But if we were to be a little more precise, and I think it does the topic justice to be a little bit precise, then we need to attribute that this is not the same thing, but these are actually a lot of tools. And of course, today and tomorrow, and actually in most of the AI classes, we will focus on large language models, which are, I hope this comes here now, no, which is a deep neural network. Another thing that might be interesting for you, or you're totally aware of this, is that the generative AI that is so much the hype now is more just a niche product of when you look at what AI can do for you in general. The big parts are supervised learning, and if you think what AI can do for you, then generating text is all nice and cool if your job as of so many people is to produce slides and to produce presentation and stuff like that. But that's really only one part, and of course in creating presentation there is no value. It's an input metric, not an output metric. And in the output metric, so actually processing data, manipulating data, making this in a way that does for you, then generative AI is just a very small part, despite we of course focusing on it now, because it's very visual and it helps probably to understand what you want to do. So, What can we do with AI? And let me just focus on very little, very small examples. The one, of course, email spam protection. It's of course always a two-way game. You create spam with AI, and then you try to protect yourself from spam with AI again. So it's a cat and mouse game. The same, of course, is true for captcha. I'm not sure if you have noticed that, but captcha are getting so complicated that it's hard for me as a human to solve them. Why is that? Because AI is getting better than us in solving these captchas, which again makes the cat and mouse game. When you go on a website and you just put an AI on that, and it perfectly knows what is a bicycle, and it can perfectly identify those things. This is why the captchas are also not so much focusing anymore on actually seeing, does the person identify the bikes, but how does the cursor move towards the thing of the bike, and is it in a very quick, very straight line, which of course would be a sign that this might have been moved by a computer, or is it in a little bit weird line, like a shaky line, like a human would do? And if we look at emails, then of course we have spam. The problem of spam, of course, is a very old one. It has been around even before the internet. And how spam used to be protected is by just having filters. So if there's a buy now, or you need to know that in the email, and if there are just too many calls to action or too many buzzwords, then there would be rules for that and move that to spam. Of course, the spammers got more aware of that and tried to move around that, which then forced the creation of AI-based spam protectors. So now an AI looks at the entirety of the email and rates on a probability score from 0 to 1, so from 0% to 100%, how likely it is to be spam. And then only the system says it's a cutoff, and if it's more likely than, let's say, 80%, we move this to spam. So what I want to say is that there are many ways where we probably use AI, where we might not be aware. If we're using Gmail and we're using AI, this is also true for the nice AI regulation that we have. For example, we must not use our spam protection filter anymore because this is not covered by the regulation that we have. Of course, we still will. Yeah, so we can automate quite a lot, also not only with AI, something we will look at tomorrow. There's, for a lot of the problems that we face, there's often a way of solving it with AI or solving it without AI, and it's more often than not a consideration. What are the goals that we want to accomplish, and why should we choose one methodology or the other? Okay, let's look at generative AI and LLMs. So, one basic, the basic new thing about generative AI is the difference to discriminative AI. Discriminative AI would just look at pictures, and if you show it enough pictures, it can tell you, is it a dog or is it a cat? So, and it basically can cluster two groups of pictures. One is dogs and one is cat. This is nice as long as you want to separate dogs and cats, but now when you want to create something new, those discriminative models cannot do that. The new generative models now can look at dog and cat pictures, find and think about those attributes that it finds for each of those things, and create out of a limited set of samples new images that might be a dog or a cat, or even something in between. Also, this already is a limitation when we think about, is it already general intelligence? Is it as intelligent as we are? We cannot estimate it, or we cannot hope that we just show an AI enough pictures of cats and dogs, and it can create a lot of cats and dogs. and by assumption or by approximation at some point it can become an elephant. That's just not possible, so it stays constrained in what it's being fed. But this is the new thing. So now we can not only say this is A or B, but also within the group of A, within the group of B, within the group of C, this is a new image, this is a new format that we can create the content. Yeah, let's leave it for that. A thing, of course, that made it very popular for us to use is the UI that we have. Show of hands, who has been using ChatGPT? Almost everybody, very, very good. Who has been using GPT-3 before ChatGPT came out? Very little people, yes. So I've also been trying it. It was surprisingly simple. The AI playground or the API playground of OpenAI is very simple to use, but of course only the simple AI that you just type in chatgpt.com and you get an interface that looks very familiar like a chatbot made it of course accessible for us to use generative AI in an instance, and of course it's free, and you can use your Google account, so super simple. And another recent development we have is that now for a short time there is, if you are in the Plus subscription, but also there are other GPTs or there are other transformer models that generate some text, like Claude by Anthropic, there's Le Chat by Mistral, and so many more. And for every problem that you have, there is some kind of optimized AI tool for that. For example, there's the GPT library in GPT Plus, ChatGPT Plus, which can help you with every problem. For example, what I'm using it quite a lot for, I talked 2 or 3 times about the Python coding class that I'm doing. Of course, I'm not writing all the content myself. I just write it into a particular GPT, say what I do, what concepts do I want to convey, and it basically writes me the code in Markdown and Python, so I can put it in a Jupyter notebook, and just have to adjust it based on their suggestions. So this is one of the slides that I'm most excited about. How do LLMs work? Because they look very much like magic. I give it a very short input and say, I'm eating, or I love eating, and I get a very sophisticated output for a computer. I love eating bagels with cream cheese, or my mother's meatloaf, or out with my friends. And just based on an input, it creates something where I say, yes, I could have said that. It's super interesting. How does it do that? And it's actually not magic. It's even better. It's mathematics. So the way it does it is it goes through the sentence word by word and tries to guess the next word and does it over and over again. So when I say my favorite food is A, then it thinks, or it calculates what is the most likely thing to now be said next. And the most likely thing might have been bagel. And now this is the new input, and it goes again and tries to calculate what is the next most likely word. And the most likely next word might be with. And it takes this again as the input and says, okay, what could be the next most probable word? Cream. What is probably the next most likely word in this kind of when we have my favorite food is a bagel with cream? For example, could be cheese. Oh, I thought I would have written cheese somewhere there. But exactly, you're now doing AI in your head. So congratulations, you've been promoted to generative AI. And the thing why it's so good at this is because it's trained on just so many words. So it might have read that quite a lot. If I'm preempting this with I'm Italian, my favorite food is maybe pizza, exactly. I'm American, my favorite food might be burger. I'm German, my favorite food, of course, is sausage with sauerkraut, because that's what all the Germans eat all the time when nobody else is around. So it just has so many references of these likely words. And of course, it has some, I wouldn't, maybe not sneaky, but smart techniques how it can adjust. So it does not force itself always to use the most probable word, but also take something of lower probability. I see you in a second. It can get some creativity, or what seems like some kind of creativity in the answers. There's a question.
This is a probability game, like depending what the next word could be.
Yeah.
For example, then the language and the grammar rules of that language, are those heavily affecting the effectiveness of like these AI tools? Because some languages, I guess, are different in how they structure the sentences.
Yeah. So the question is language specific, and does the grammar of the language influence the generated output? Yes and no. Yes, in the way that if you're not well trained in a particular language, let's say it's a niche language like Native American language, for example, where there might be a very limited set of text, then the generation for this kind of text is indeed very, very poor. The other thing it does, however, is it does not translate directly to language, but it translates to tokens. So it builds its own meta-language out of what it does, and retranslates this meta-language then in the original language. However, it's true what you see, the sentence structure seems to be a little bit biased towards standard structures. So it's SPO, subject, predicate, object. That's usually what happens. Which is a good leeway to, it very much depends on what you input, what you get as output. So for example, if you look for nurses, let's say you ask ChatGPT to create a picture of a nurse. It's very likely that you get a woman in a blue scrub. And why is that? Because a lot of pictures of nurses depict female people in blue scrubs, which of course can be problematic if you say, okay, you want to have a rather diverse representation of nurses and might want a male and a female, or just looking for a male nurse or something like that. And of course the opposite might be true if you're looking for a construction worker, which most pictures online are male people with a hard hat and a yellow security vest. So this is probably the thing you get in. So the input that you feed your models with will determine the output, which then also, there's no need to cry out loud that those companies like OpenAI are discriminating against somebody. I think they don't have the capacity or the resources to be that vicious, but they just don't have the resources to preempt every single prompt with just try to stay neutral. You know, what actually happens if you use ChatGPT, for example, there's a huge data pipeline that's in front of your prompt, that when you say you want a photo of a nurse, then the data pipeline that is being built by OpenAI might preset it with be gender open, be open to gender, consider a male nurse or something like that. But if you're just working with the API, with a vanilla version of the LLM, in this case, sorry, it's not the LLM, but it would be DALL-E, so it would be a diffusion model, then it would probably create you something that is that is truest to the training set. And this is something, of course, that you need to be aware of when you interact with AI. What notions that you don't want, what biases could be in the data set that you don't want to have in your output, that you don't want to represent, which again does not mean that AI is bad in some way. AI has no moral compass. AI does not have any concept of morals whatsoever. At least generative AI does not. But it means that you need to be aware of, and if AI creates something that you think is a little bit weird, check it, might it be a input bias, and do you need to redo that? One small anecdote is that in 2018, I think it was, Microsoft released a generative AI bot to Twitter, when it was still called Twitter. And the experiment was that the chatbot is completely vanilla, and with the interactions of the Twitter users, it would create its personality. So, of course, very input heavy what the input has. And of course, everybody who uses Twitter knows exactly what happened. The trolls were feeding it with neo-Nazi content, and within hours, this AI was super right-wing, right extreme, was tweeting only anti-Semitic posts and doing stuff that Microsoft had to take it down within one day because, again, the input that the users gave it were not a nice social experiment, but they really tried to troll Microsoft and show you can just bias the input and make the most horrifying artificial intelligence out of that. Of course, Microsoft hopefully has learned out of this, and of course, if you look at the recent AIs, then a lot of them have learned out of this, and this does not happen anymore. Nonetheless, there are biases in the AI models that nobody might be aware of, so you should be aware of this. Do something, yeah. Something you can read up at home. There might be stereotypical biases, gender biases, cultural biases, political biases. There's a website, I forgot the name, that ranks the political orientation of LLMs. It's super interesting. So OpenAI apparently is a little bit leaning towards the left. Gemini by Google is a little bit to the middle and stuff like that. You can read it up. And this website claimed, or a lot of commentaries claim that it's corporate policy to push it in one way or the other. I would question that if the AI had anything from being a little bit leaning to the left or to the right, it's again just the bias that is being fed with the content it has and the weights and biases. One thing that I will look in 2 slides, but which should be important to remember, the LLMs that we're working with have trillions of parameters. Those trillions of parameters, a machine learns, so not a human. There was not a human who put trillions of parameters that also have interactions with each other that no human can foresee. So to say a bias is intentionally implemented in an LLM is a little bit far-stretched, given the complexity of an LLM. And now we have, so that was generative, now we have transformers. The rise of attention. It happened in 2017. Attention is all you need is the name of the paper that basically changed everything. And the change, why any LLM or anything that we are using now is of use is because of attention. Because we used to have the issue that if you give an LLM a input sentence like the teacher taught the students with a book, then there was a linear connection between all of the words and not really what the sense means. So if we read the sentence, of course we know what part of the sentence means what. that there's a student who is strongly connected with the teacher, and there's a book basically in between the teacher and the student. That is something that we do in our heads very automatically, but of course AI cannot think like this because it has no concept of what a teacher is, it has no concept of what a student is, it has no concept of what a book is. And even if we leave away the word taught, then we can say, okay, it's very likely that the word in between here might be taught, because we know, we have the attention what this sentence is. It could also be beat up, but it's rather unlikely that the teacher beat up the students with a book. So we know that the AI did not know. Thus, the efficiency of the processing was very, very limited, and the quality of the output was not as strong as it could. So this paper now said, okay, we need an attention map and say which concept is connected very strongly to which. So the teacher is very much connected with the book and very much with the student. And we already see that those are the connections that are most crucial, teacher to book and teacher to student. And if we look at the vice versa, also to student to book. And now the AI can work with this attention way better in understanding the sentence and understanding what the next sentence could be. The next sentence could be about the book was about mathematics or something like this, because we now know, okay, what does it mean? So we do not have only the linear sentence, but a weighted sentence with attention. Am I making this clear or am I confusing you? Both. Okay. Maybe we have this. Yeah, I have another example. And this then gives us the fantastic thing. Again, AI does not have a concept of what a book is and what a teacher is, but it has a high-dimensional embedding space. So this embedding space that we see here could look like something like this. It's here three-dimensional. I said there are billions of parameters, so in real life, those spaces can have a billions of dimensions, which of course is very hard to represent. And in this space, there might be clusters. For example, there might be one vector that points to France and another vector that points to Germany. And if we now move, or if we take a vector from Germany to beer and take this vector and put it to France, then this vector probably will go somewhere in the area where wine will be. So this is the idea that we have similar things are in similar distance of the concept that they might be related to. Does make sense? So we have a high-dimensional space that embeds a meta-meaning of the words, more correctly token, in a space that the AI can guide to. So it basically goes through a coordinate system, not through a dictionary, but through a coordinate system, which has embedded I see it's super complicated, right? We will look at this 2 more times this weekend, which might make it a little bit more viable. I also don't expect you to go through it mathematically, but I think it's important to know that the AI does not really know what it's saying, but it has a visual representation or a mathematical representation of the space and where different things might lie in the space. So now we have the space. Of course, the AI does not work with words because words are clumsy, are not nice. Numbers are way nicer. So before we embed, we tokenize those things. So for example, let's say my input is my favorite food is A. So the first thing the AI does is it goes to numbers. It makes a vector out of that with those numbers. It goes through the neural network. We will look at the neural network tomorrow, how this works and what it does. And after it calculates all those stages at the neural network, it comes out with a token ID, which is A42, could be a bagel, for example. And then it translates back the token ID to the completion number, and voila, we have a sentence. Does look a little bit complicated for the small task we do, right? And it is. It is completely wasteful. So if you just want to play around with AI, it's in no way an efficient method of solving problems, but we still can do it because our computers are so powerful by now. And this is then going through the entire process, and we just want to create a fun little poem about bagels, cream cheeses, and food. And at some point, GPT will make a decision for you. We will look at this today, I think. Has to decide if it stops with a stop token or if it continues with further tokens. This decision you can partly influence in ChatGPT. You cannot so much influence it, except for preempting ChatGPT. In the prompt engineering, we can look at this by saying, stay brief, then it would rather probably go with a full stop, or explain your reasoning, and it probably would go on. And as I said, it does not really know. It has some meta knowledge or some meta meaning to all the stuff it does, but it does not know what food is, it does not know what a bagel is, it does not know what cream cheese is, and it also does not know if it's correct. So when I ask it my favorite food is a bagel with cream cheese, it just writes that because it thinks it makes sense, but it has no idea if my favorite food is a bagel with cream cheese. It just does not, and it also would not get the idea of asking me, I don't know, tell me what is your favorite food, because it has not of these concepts. Wonderful. You know there are a lot of different models. I think this goes a little bit in depth. There are things that the thing that you should know is that GPT is one of the models and a very famous model, but there's also Claude, which I would recommend you look into. Gemini, something that you get for free from Google, thank you. Llama, which is by Meta, Mistral, which is a French company actually. So just go out there, try different tools, and what you will find, and what will be also part of the exercise, is that different tools will give you very, very different results. So there's also not a right and wrong. I already said this, it becomes super, super expensive of running these tools, and they are very computational intensive. I read this on LinkedIn. I did not check if this is true, but this LinkedIn post claimed that generating one image in Delhi generates as much CO2 as eating a schnitzel. I don't know about that, but sounds like it could not be too much off. Okay. Also, that is a little bit too technical right now. And what actually happens when you give ChatGPT one single input, it creates 10 billion calculations to create an output. So 10 billion vector calculations generated to create an output. And this is with a 3.5, so this is with a free version. If you're using GPT-4, it's even heavier on the computation. And this is all happening on some machine that you don't even see. And if we look at GPT 3.5 and we print the entire model out on sheets of paper, we get on DIN A4 paper, we get an 8 kilometers high tower of paper with just this single model. So I think it becomes, I think it becomes evident that it's not very efficient, and that maybe on the other side, that the human intelligence with our brains running at, I think it's 20 watts, something like that, 20 or 60, I forgot. It's still rather efficient what we can do with our natural intelligence between our ears. That was a question.
Maybe not that related to AI as such, but it's a bigger question. Given the energy demands of these models, how important is it to continue building these? Because
Yeah. So the question is more or less the ethical implications of the energy demands for the use cases that we have. And this is very true. So we are spending a lot of electrical energy on doing things in GPT and ChatGPT. Also, those models run almost all of them, almost all of the services run at a loss, at a huge loss. So it's also not economically sustainable. And this is a personal opportunity now, but I think the future needs to show where this is going, and if we are at a stage where every one of us for 20 euros a month should have access to an AI that gives him or her 10 jokes, 10 dad jokes on demand, if this is really necessary, or if we need to step back a little bit. Of course, what we're seeing now is the cutting edge technology in the hands of everybody's palms or wherever, which is cool, and it's a nice preview. But I think the future needs to go on something that is sustainable for every party. And I would love to see a LLM run locally on devices where I need to control, or I can control the energy demands and all those demands that the model states. And you're totally right, the current modus operandi of generative models is absolutely not sustainable neither for the environment nor for the companies who offer them. Okay, we have one more concept. Let me quickly show how much I'm behind. Very much. But context window is just too important to ignore. The concept window is the window of tokens, the window of content that remains in your conversation. That's as easy as it gets. So we already saw that whatever you give the machine, it will create a huge vector out of that and it'll throw them in a machine. So of course the length of this vector, at some point it needs to be cut off, because the longer the vector gets, the more complicated it is to calculate and that stuff. So, so we need to stop it at some way. And you might have noticed that in a very, very long conversation that you have with one ChatGPT, that it forgets some information that you gave it to the machine at some point. And the reason why it does that is that it only takes the last n, or that token, tokens of what you were saying into its context. And it always takes the last n contents, in the case of ChatGPT at least. So you cannot just say to ChatGPT, oh, I wrote some bullshit, please ignore what I wrote last. It's still in the context window. It will be part of what it generates next. You can also not say, here is a 200-page document, please think of all of that and give me a brief summary, because those 200 pages might be bigger than the context window that you get. The open version of most of the generative AI tools have a context window that is somewhat limited. I think in ChatGPT it's round about 10 DNA4 pages, so everything that's longer than that will be before the context window. So if you give it your dissertation, if you give it your master thesis or something like that, that will be longer than the context window. And when you say, please write me a summary, it will probably just summarize the last 10 pages or so. The other problem, if you now go to a more premium model, which is a way longer context window. Again, if you write something that should not be part of the conversation, it will still be. You cannot say just ignore that, because it will not ignore that. It will read through it and will read through the comment, please ignore that, but might not know exactly where to frame it. So to keep this very short, it's very, very important to be aware of the context window and to not, for example, what practical implication, for example, does it have when you open a new chat Don't use it for several purposes, in particular if it's a purpose that you want to create the output or you want to use the output for something specific, because it will use, if you first let it create a chicken curry recipe and then next a LinkedIn post, then the chicken curry recipe might be part of the LinkedIn post. Depends what content you want to create, of course, but it makes more sense to have clear chats with clear context windows that just include the context that is relevant for whatever you want to do. Yeah, context window, how long does it get? You can also see it's very much dependent on what you do. Token limits, a token roundabout is a syllable, can be a little bit longer, can be a little bit shorter. Tokenization is not really that much of a complicated process, but every of these companies, every of these projects has to define the tokens at one point, and usually it's around one syllable. You can see that ChatGPT allows you for a rather big content, while the cheaper versions have a rather small content. And now let's go, I really go quickly through that, but we want to look at one specific thing. This is actually part of the things I have online. There is a wonderful gentleman, I think from Seattle that is, has made public a Excel sheet with the entirety of GPT-2 in it. So all the weights, all the biases are implemented in Excel. And you can write in the first sheet of this Excel sheet a prompt, and you can write calculate, then you can wait, and wait some more, and then Excel will create the output for you, which is very, very cool. We will not do this here because there's also a problem in the Mac implementation, so it works better on a Windows machine, and also because I'm already very much behind. But we will look at what this does, and you can come back to this again. So this is what we will do over the 6 days. Today we will only check the data pipeline of LLMs. Tomorrow we will go into general neural networks. So what happens in this process? We give the LLM an input. Again, look at this at home, look at this in the Excel spreadsheet. If you understand the Excel spreadsheet, then you understand in a very high degree of detail how LLMs work. And you're basically ready to go to build your own. I think I've built an implementation in a Jupyter Notepad, how you can build this with Python or rebuild this with Python, so you can go ahead and basically build your own LLM. Right after this morning, I think this is great value for you that you can already get out of this. Input for the LLM. Mike is quick, he moves. We're waiting for an output. What happens in the LLM? The first thing it does is it does embedding and tokenization. So first, we already know that every syllable, these are the actual values that tokens have. So Mike, for example, is 16,073. A full stop is the token 13. And we create out of that the tokens. Again, why? Because computers want to calculate with numbers. Computers are very good with numbers, but not very good with words. So are computer scientists. Those embeddings then go to this embedding space. So it is a high dimensional, those are coordinates now. I did take the time, unfortunately, to make this coordinates, but it would go now in this embedding space, this high dimensional space, and say, okay, every single token is somewhere in the X, Y, Z, and so on space, and has some particular coordinates. So now it's embedded. So now we are completely away, discontinued. The computer has no idea, again, if I was saying Mike or Sally, if I was saying quick, fast, or anything else. It just has an idea what coordinates in this coordinate space do I have. Now I give it an attention. This was the important concept that made LLMs helpful for what it does to generate text. That is, will you show me? I have no show for that. So this attention is multi-headed. This is what's happened in the neural network. We will go through the neural network, calculate a potential next word. We will do that iteratively to, for example, see what are the important connections that we have. For example, what does quick mean in this consideration? This is what we do in our heads very, very easily. Does it quick mean in the sense of running? Does it quick mean in the sense of short? Does it quick mean there are very many ways we can use quick, and those attention and neural network will say, okay, quick is in the sense of moving fast. And once we have done this, GPT-2 does this 13 times over again, so it does attention, it does, calculates the neural network, goes back to the attention, goes back to the neural network, and so on, 13 times. And then we have done this. We have ABBA, for example, as the output coordinate. We find the token on that we have, give it to the so-called language head. So the language head is basically the other direction of the tokenization, and say, okay, now I'm calculating from the token, the word or the syllable, and say, for example, this could be fast. And the output now is Mike is quick, he moves fast. And it's a very, very trivial sentence, and this is everything that happens in between. So, what was the question? Sorry.
That by this process, the more we use it, the more words get removed from the language because it always refers to the most used words.
Yes and no. One step I jumped over here is that between the neural language and the language head, the neural network and the language head, you don't only get one token, but you get a probability of several tokens. So it's not a 1 or 0 calculation, but it's a calculation that could have quickly is the most probable word, then fast is the next probable word, and you get an entire list of probable next words. And with a parameter that's called temperature, you allow so if you send the temperature to 0, it's just a definition that it's being called temperature, but then the model would always go for the most probable version of the word. That could create a less probabilistic and very deterministic thing, but might be very important if you're looking for an output that a next algorithm needs to work with. So the next algorithm only wants fast, and if you give it quickly, then it might be a little bit confusing. On the other hand, if you want to do something creative, you want to probably increase the temperature and give the program the opportunity to be a little bit more random in the selection of the next word. Whatever is true that it's always somewhat a regression to the middle. So it's very rarely that ChatGPT or any LLM surprises you with a very uncommon phrase or with a witty commentary on something. This is something that just does not do it because, again, that was the commentary I was doing with generative, that if you just show it cats and dogs, it can create new cats and dogs, but it will not create, unless it has already seen that, a mixture of a cat and a dog, or a cat, dog, and a dolphin, or something like that. And there's those creative things are still things that is very unique to the ability of thinking of the human. Or other AIs probably, but not LLMs. Okay, wonderful. Is now either everybody confused, or tired, or wise, or a mixture of the three? Mixture? I hear mixture. Okay.
Can I ask you,
Of course.
in a very layman's term, okay?
Yes.
Let's say all of us when we register for this class, let's say we are supposed to put our nationality, okay? Germans,
Yes.
whatever. And then I accidentally, as a joke, I put, let's say, Marshall from Mars
Yeah.
in Korea.
Yeah.
And we ask ChatGPT, that's the data they have.
Yeah.
We ask him, who's the guy sitting, right in front of you?
Yeah.
Will it answer that?
Yes.
And there's a specific joke about the Martians. So
Yes.
either answer me as a Korean.
Yes. So the question.
Did you understand my question?
Yes, the question is if you give it some random data that's clearly a joke, like you say you are Martian, and ask it a question about you, will it consider you a Martian or will it understand the joke?
Yeah.
Is that the question? It will not get the joke, most likely. That it will take for granted what you give it as input. It has no critical thinking abilities of if this is what you write makes sense or does not make sense. You can let's have two scenarios. You say, I'm a Martian, who are you talking to? Then it will say, okay, I see in the context window, you say, I'm a Martian, then answer is, I'm talking to a Martian. Will not doubt that. But if you now say, do you think it's likely that you're really talking to a Martian? Then it might go through the calculation again and go through, for example, sample data that you have. And this is one way of how to think that. It has read in a lot of forum. It's super unlikely to talk to a Martian. So it will, given the prompt, is it likely to talk to a Martian? The next token is very likely to be a no. So again, how it still will guess what the next token is based on what you already give it to him. So but this is also very important. What we will talk in prompt engineering then, the way of your question will very much influence the way of your answer. For example, when you give it a very stupid business ideas. Think of the stupidest business ideas that you can up with and say, give me feedback on that. It will always be leaning very much to be very enthusiastic and very positive about that. So if you wanted to have critical feedback, then you need to write the prompt in ways, what do you see problems with that? Why do you think this could not work? And say, okay, let's try to find next tokens. Let's try to find answers that are critical. If you just say, give me feedback on that, then it has learned that most of the time when people ask for feedback, in particular on the internet, they're not really asking for feedback, they are asking for encouragement. So it will say, don't know, what do you think about a Korean restaurant in space on the ISS? Then it will say, that's a fantastic idea. There is not a single Korean restaurant on the ISS. Let's try that. And if you say, okay, what could be problems with that is, yeah, first of all, there's no kitchen, there's no space, there are no customers. So this is what you as the user has to prompt it with. All right. This is the aforementioned Excel. Again, it's linked in on the T12S website. It's insanely interesting how to look under the hood. What basically you see here is you type the prompt here, then you have the tokenization here, then you have all the blocks, all the layers. It goes through the neural network, and then at the last sheet it gives you the answer. So I highly recommend it to you to take an hour of your time and to look at this in detail, because after that you will really understand what an LLM does. Maybe not exactly why it does what it does, but how it works. And it's super interesting that this is something that is actually not that hard to do once you have understood it. Okay, because I have confused you, I want to have some feedback on how much I did so. And for that, of course, I have another slide.